A heat index was measured on July 16, 2023, that the human body cannot physiologically survive. Not in a furnace, not inside a sealed car, in the open air, at an international airport on the coast of the Persian Gulf. The official reading was 152 degrees Fahrenheit, 66.7 Celsius. This is not a weather report. It is the announcement of a biological boundary being crossed. And the strangest part is not that this temperature was reached. It is the place it happened, and the mechanism that is now making it happen more often. To understand what is unfolding, you have to understand the air over the water. The Persian Gulf, also known as the Arabian Gulf, is a unique basin. It is shallow, it is geographically walled off from cooling ocean currents, and it is surrounded by some of the most intense desert heat on the planet. For millennia, this created a predictable cycle. The sun superheats the land heats the water, and the water evaporates, creating a dense, oppressive lid of humidity. But now, that cycle is breaking its own ceiling. The water is getting warmer, faster, holding more energy. This adds more moisture to the air than ever before. This is the detail the headlines about record heat do not fully capture. The danger is not the number on the thermometer. It is the amount of water vapor in the atmosphere. The human body cools itself by sweating. Evaporation pulls heat from the skin. It is an evolutionary masterpiece. But when the air is already saturated with water, sweat cannot evaporate. It just drips. The body's cooling system fails. This is the scientific reality of what is known as the wet bulb globe temperature, or WBG. It is the point where air temperature and humidity combine to make cooling impossible. That limit, the absolute threshold for human survival beyond a few hours, even in the shade with unlimited water, is 35 degrees Celsius, 95 degrees Fahrenheit. On July 16, 2023, south of the Persian Gulf International Airport in Iran, the wet bulb temperature crept past that line. For people living and working across the coasts of Iran, Iraq, Kuwait, Saudi Arabia, Bahrain, Qatar, the UAE, and Oman. This is no longer a future threat discussed at climate conferences. It is a present-day physical reality. It is a condition. Zoom out, and the daily pattern reveals something more insidious. For most of history, the brutal heat of the Gulf region would break after sunset. Night brought relief. It brought a reset for the body. That is no longer guaranteed. As of June and July 2026, occupational health observers in the region report that the lethal combination of heat and humidity no longer dissipates after dark. Temperatures are hovering around 90 degrees Fahrenheit all night. The air is so thick with moisture from the hyperwarm Gulf that there is no escape. The human body gets no chance to recover. In response, industrial and construction sectors are being forced to rewrite the entire calculus for labor. Overnight shifts, once a refuge from the sun, are now becoming just as dangerous. The work cannot stop. So the risk is simply absorbed. This is the part nobody is putting on the evening news. We are watching entire regions approach the hard red line of human habitability. We are not talking about comfort. We are not talking about economics. We are talking about the point at which a healthy human body, outdoors, begins to cook. The United Nations University and Human Rights Watch have been tracking this for years. Their warnings are no longer theoretical. The 152 a year ago wasn't a freak event. It was a warning shot. One that millions of people heard loud and clear. 10,000 kilometers away, another Gulf is rewriting the rules. Not of human biology, but of atmospheric physics. For the millions of people who live on the coast of the Gulf of Mexico, the fear is not a heat index. It is a storm category. And the engine that powers those storms is getting hotter at a rate that scientists are still struggling to fully model. Between 1970 and 2020, the Gulf of Mexico warmed at twice the rate of the global ocean average. This is the finding of a landmark 50-year study, published on February 1, 2023, by a team led by Dr. Jiankun Wang at the National Centers for Environmental Information. They analyzed 192,890 individual temperature profiles to arrive at a single stark number, a warming rate of 0.19 degrees Celsius, or 0.34 degrees Fahrenheit, per decade. That may not sound like much, but in oceanography, it is a tectonic shift. And 80 to 90% of that heat is not at the surface. It is stored in the upper 1,000 meters of the water column. The system is building a thermal battery. To understand what that battery does, you have to understand how a hurricane works. A hurricane is a heat engine. It thrives on warm surface water. But it is also its own worst enemy. The powerful winds of a major storm churn the ocean, dredging up cold water from the depths. This cold water acts as a brake, robbing the storm of the fuel it needs to intensify. It is a natural negative feedback loop that has for eons put a ceiling on how strong a storm can become. In the Gulf of Mexico, that brake is disappearing. The deep reservoir of warm water, what scientists call high ocean heat content, means that when a hurricane churns the sea, it does not find cold water. It just finds more warm water, more fuel. The brakes are gone. The storm has only an accelerator pedal. Meteorologist Jeff Masters, a former hurricane flight meteorologist, calls this deep heat rocket fuel. It is the primary reason for the terrifying phenomenon of rapid intensification, where a storm explodes in strength just hours before making landfall. He has calculated that for the strongest storms, just a half degree Celsius rise in Gulf surface temperatures translates to roughly a 30% increase in damage potential per decade. And then there is the storm that proved him right. On October 28, 2025, Hurricane Melissa made landfall in southwest Jamaica. Initial reports clocked its winds at 185 miles per hour, a catastrophic Category 5. But here is the detail that tells the real story. 4 months later, on February 26, 2026, the National Hurricane Center in Miami released its final post-storm analysis. After reviewing all the data, they officially upgraded Melissa's maximum sustained winds, not to 186, not to 188. They upgraded it to 190 miles per hour. That number, 190, tied Hurricane Melissa with 1980's Hurricane Allen as the strongest Atlantic hurricane in recorded history. It was a storm that found the deepest, warmest patch of water in the Caribbean, inhaled its energy, and ran right over an island nation. Andy Hazelton, an associate scientist at NOAA's Cooperative Institute for Marine and Atmospheric Studies, flew through that storm. He is a hurricane hunter. It is his job to fly into the worst weather on Earth. He described the flight into Melissa. We hit an updraft-downdraft combination that jolted the plane pretty good. I had experienced very intense storms before, but Melissa was probably the worst. The physics of the storm, supercharged by the ocean's heat, were creating turbulence beyond the known scales. The storm was not just stronger, it was fundamentally more violent. The story of Hurricane Melissa is the story of the Gulf's future. In mid-May of 2026, just before the official start of the hurricane season, the Gulf of Mexico tied its all-time sea surface temperature record for that time of year. Its ocean heat content, that deep reservoir of fuel, was measured at its second highest level ever recorded. The system is primed. The rocket fuel is in the tank. The question is no longer if a storm will find it, but when, and what will be in its path. But the impact of this heating Gulf is not just on the coasts. It is not just about hurricanes. As of the first week of July 2026, a persistent high-pressure system, a heat dome, has parked itself over the United States. It is drawing massive amounts of moisture and warm air directly from the Gulf of Mexico and pumping it north. This is the engine driving extreme heat index values of 105 to 115 degrees Fahrenheit across the Midwest, the Mid-Atlantic, and the Northeast. The July 4th holiday weekend is blanketed in widespread heat alerts affecting millions of people, hundreds of miles from the sea. The Gulf of Mexico is now exporting its heat inland. It is changing the weather for the entire eastern half of the continent. The story extends even to the smallest scales. In the shallow estuaries of South Florida, like Tampa Bay and Florida Bay, the water is warming up to 70% faster than the open Gulf. These nurseries of the sea, the foundation of the marine food web, are being cooked. The top few meters of the global ocean store as much heat energy as Earth's entire atmosphere. And in the Gulf of Mexico, that energy is accumulating at double the average speed. A storm does not need to form for the effects to be felt. They are already here. They are in the air over Chicago. They are in the water in Tampa Bay. They are in the post-storm analysis of a record-breaking hurricane. The Gulf of Mexico has become a vast thermodynamic machine, and its output is extreme weather. And then there is the signal from the north, the one that is quieter, but in many ways more alarming. It is happening in a body of water far from the desert heat of the Persian Gulf and the tropical energy of the Caribbean. The Gulf of Maine. A 36,000 square mile semi-enclosed sea stretching from Cape Cod in Massachusetts to Nova Scotia in Canada. Historically, this was a cold sea, defined by the frigid waters of the Labrador Current sweeping down from the Arctic. It was a place of cod, lobster, and dense fog. It is now one of the fastest warming marine ecosystems on the planet. This is the part that defies easy explanation. Between 2004 and 2013, the Gulf of Maine warmed faster than 99% of the world's oceans. Not 90%. 99. The data, first published in the journal Science on November 13, 2015, sent a shockwave through the oceanographic community. A team led by Dr. Andrew Pershing, then at the Gulf of Maine Research Institute, documented what he called a shocking upward trajectory. It was as if an entire sea had a fever that would not break. On August 23, 2012, its surface temperature hit 68.99 degrees Fahrenheit, 20,055 Celsius. An unprecedented marine heat wave that shattered all previous records. To understand why, you have to picture the geography of the seafloor. The Gulf of Maine is shaped like a bathtub. Its deep basin is blocked on its southeastern edge by shallow underwater shelves, like George's Bank. For centuries, this bathtub was filled by a cold water tap, the Labrador Current. But that tap is being turned down. As the Arctic melts and fresh water pours into the North Atlantic, it is disrupting the large-scale ocean currents. The cold, dense Labrador Current is weakening. At the same time, the Gulf Stream, a powerful river of warm water flowing up from the south, is shifting northward. The result is what Dr. Pershing described perfectly. Essentially, shifting ocean currents are functioning like a hot water tap that dumps directly into the Gulf of Maine. The cold water supply is being choked off, and the hot water supply is being rerouted directly into the basin. The bathtub is filling with warm water, and the drain is partially blocked. The consequences have been swift and brutal. The Atlantic cod fishery, the very industry that supported New England for centuries, collapsed. The cod, a cold water species, could not adapt. They moved north or died out. Lobster populations, seeking colder water, began a massive migration northward up the coast, changing the fortunes of fishing towns in Maine while devastating those in southern New England. The entire ecosystem is being rewired in the span of a single generation. What was once a gradual academic discussion about climate change became an immediate existential crisis for an entire region's economy and identity. The story of these three gulfs is the story of a system under stress. In the Persian Gulf, the stress is on the absolute biological limits of the human body. In the Gulf of Mexico, the stress is on the physics of the atmosphere, breeding storms of unprecedented power. And in the Gulf of Maine, the stress is on the planetary circulatory system itself, as the fundamental currents that have governed our climate for millennia begin to falter and shift. Each gulf is a different chapter in the same narrative. They are canaries in the coal mine, sending signals of a planet entering a new thermal state, a state for which our infrastructure, our economies, and our own biology are not prepared. The heat accumulating in the Persian Gulf is not just a local problem. The deep heat in the Gulf of Mexico does not just threaten platforms and ports. And the systemic unraveling in the Gulf of Maine is not just about fish. They are all connected. They are feedback loops. A warmer Gulf of Mexico fuels a heat dome that puts more stress on the eastern seaboard. A disrupted Atlantic circulation, the one heating the Gulf of Maine, has unknown consequences for weather patterns across Europe. The heat energy being absorbed by the oceans is not staying there. It is being released back into the atmosphere as turbulence, as humidity, as droughts, and as floods. The numbers are no longer abstractions. 2 times the global average. 30% more damage potential. 99% faster. 190 miles per hour. 152 degrees Fahrenheit. These are not data points for a future report. They are measurements of our current reality. They are the vital signs of a planet in distress. And so 3 truths now hang over these vast bodies of water. The nights are no longer a guarantee of relief in the Middle East. The depth of the ocean is no longer a brake on the power of a hurricane. And the ancient cold currents of the north are no longer a reliable defense. The question is not what will happen if the gulfs continue to heat up. They are already doing it, and faster than our models predicted. The real question is how we will respond to the world they are creating. How do you manage a fishery that has moved 100 miles north? How do you ensure a coastline against a storm that intensifies from a Category 1 to a Category 5 in the time it takes to drive to work? And how does a society function when the air itself becomes deadly? The heat stored in the upper Gulf of Mexico from the last 50 years is still there tonight. It is a silent, invisible reservoir of energy, waiting under the waves for the next atmospheric disturbance. The humidity over the Persian Gulf is still trapping the day's heat against the Earth's surface, refusing to let go. And the warm water of the Gulf Stream is still pushing its way into the deep basin of the Gulf of Maine, slowly, relentlessly, rewriting 1,000 years of biology. The process is not stopping. It is accelerating. And somewhere out over the Atlantic, the next season is already beginning to stir.